Hi algebra students, Mr. D'Amico with another lesson for you. We are talking about slope and rate of change today. Our goal is to calculate the slope and the rate of change. So first let's talk about what is the slope. Basically the slope is the steepness of a line, and it also is how the line changes vertically, which is the y direction, versus how it changes horizontally, which is the x direction. Some people say change in y over change in x. We could also say rise over run. Again, the rise is the y direction, the run is the x direction. All right, how do we find the slope given 2 points? Well, first of all, we should have 2 points, and we can label them right now x1, y1, and x2, y2. And slope is represented by the letter m from slope-intercept form, which we'll learn in our next lesson. So if I want to find the change in y and the change in x, like I said earlier, we do that by subtracting. So we're going to take y2 minus y1, because that would be the rise, over x2 minus x1, because that would be the run. And depending on your answer for your slope, there are 4 possibilities that can happen. If you have a positive slope, your line will be increasing from left to right, just like that one looks down there. You could also have a negative slope, which means your line would be decreasing from left to right. What happens if the slope is 0? Well, then you would have a horizontal line, and sometimes you get a 0 in the denominator, which does not equal 0. That means that that number is undefined. That means that it has no slope, and that line would be vertical. All right, here's 2 points. Let's actually find the slope. The first thing that I'm going to do is I'm going to label my 2 points, x1, y1, and x2, y2. I do this because I want to be sure that I am subtracting the correct values. Sometimes I could, maybe mix up an x and a y, or depending on how the problem looks, if I don't have it labeled, I have a greater chance of making a mistake. So that's why I want to label my points so I can be correct. So our slope now is going to be negative 2 minus 4 over 1 minus negative 1. And if you look at the denominator here, since we are subtracting a negative, that's essentially adding. So sometimes we're actually adding. I'm going to change that to 1 plus positive 1. And then my final answer is going to be negative 6 over 2, which simplifies to negative 3 over 1, or just negative 3. So that slope is negative, which means if we were to graph the line containing these 2 points, it would be decreasing from left to right. If you look at number 2, the line is decreasing from left to right, so this should have a negative slope if we do it correctly. And if I look at this line, I can see 1, 2, 3, 4 points that are clearly marked. So students say, Mr. D'Amico, what 2 points should I use? And honestly, it doesn't matter. Any 2 points that you use will give you the same slope regardless of where they are on the line. So I'm going to choose those 2 points there. And that first one looks like it's negative 3, positive 1. Second one is 0, negative 4. So now I'm actually going to do my calculations. Once I label them again so I don't make a mistake, please do that as well. And let's figure out what the slope is. Negative 4 minus 1 over 0 minus negative 3. Again, minus a negative, let's change that to 0 plus positive 3. This time our slope will be negative 5 over 3, and it is a negative slope because the line is decreasing from left to right. So we can be confident that we did that problem correctly. Number 3, so we found the slope just given 2 ordered pairs. We found the slope from a line on a coordinate plane, and now we're going to find the slope using a table. So again, you pick the 2 points that you want. I will choose the first 2. I'm also going to label them again so I do not make a mistake. And then I am going to start subtracting. Let's go with 6 minus negative 2 over 5 minus 3. I'm going to change that top again to 6 plus positive 2, which is going to give me 8 over 2, which simplifies to 4 over 1, or just 4. So if we were to graph the line containing these points, since there's a slope of positive 4, the line would be increasing from left to right. All right, what is the rate of change? Well, the rate of change is just like the slope. It is a ratio that describes how one quantity changes in relation to another quantity. So just like the slope, the y values changed, we compare the change in the y values to the change in the x values. That's what rate of change is. It is a ratio like slope is, and it describes how one quantity changes in relation to another. So let's do an example so you can actually see. Here's a couple of examples. Miles per hour. So I can drive 55 miles per hour. We're comparing miles, how far you can go for how long it takes. Also, we could compare 3.2 feet per second. Maybe that's how fast someone is walking, or jogging, something like that. So that is rate of change, very similar to slope. Okay, so here we have another table, and this time instead of just x and y, we actually have cost in dollars and weight in pounds. And if we look, this is like our x value or our domain, and this is like our y value or our range. It's just like the last one we did, except again, instead of x and y, we're going to call the x values the cost in dollars, the y value the weight in pounds. So which 2 points should we use? Again, entirely up to you. I'm going to pick those two, and I am going to label them, and then I am going to find my rate of change. So we're going to go 22 minus 11 over 16 minus 8, which is going to be 11 over 8. And if I wanted to use the correct terminology for this problem, I would say that's 11 pounds to $8. And when we're talking about rate of change, it also helps, like when I did that example before when it said miles per hour and feet per second, it helps if you have the second quantity as just like 1. So that was like 55 miles per 1 hour, 3.2 feet per 1 second. And if I divide 11 by 8 here, I'll get 1.375. So I'm still comparing pounds to dollars. So I can get 1.375 pounds for every $1 I spend. That's our rate of change. So it would make sense that since I'm spending more dollars, if I wanted to, for example, spend $2, the pounds that I would receive would increase because that is a positive number here. So this rate of change is positive, which basically means the slope is positive. So if we were to graph this line given this table here, it would be increasing from left to right. Number 5, another table. We are comparing time in minutes to distance in feet. I'm going to pick the first 2 points again and label them. And I'm going to find the rate of change. How about 24 minus 12 over 4 minus 2? Giving me 12 over 2, which is 6 over 1. And I'm just going to go ahead and label that because the y values are in feet. So I can go 6 feet for every 1 minute. And you could say that my rate of change is 6 feet per minute. Again, this is a positive rate of change. That means if we were to graph this on a coordinate plane, the line would be increasing from left to right. Every minute that goes by, I can go another 6 feet. I can travel another 6 feet. Excellent. All right. Thank you so much for watching the video. I would like you to try the problems on the back of the worksheet and write down any questions that you have. Please find the slope and rate of change from tables, graphs, and just given points. Have your questions ready to go tomorrow, and I will see you guys tomorrow. Have a great day. Bye, guys.